All right, folks, let's get out your note page, your packet that we went over yesterday. On the next page, there is a section to go over friction. And we're going to go through and talk about friction and type of frictions today, types of friction, excuse me. So go ahead and follow along with me and take notes as we do this. So as you look, the first things we'll talk about is what is friction? Well, friction, you've probably learned before, is something that can help warm up your hands when you're cold. You might rub them together. But friction is a force that opposes motion between any surfaces. And those surfaces could be your hands in this case, that are touching each other. So if you have two surfaces that are touching each other, there is friction, which is a force between them. Now, friction can be helpful and help us, can work for us, or it could be not helpful. Now, in the case of the pictures below, you'll see that these are both helpful frictions. The friction between the paper and the graphite in your pencil, or even the ink in your pen as you're writing right now, that friction leaves marks on the paper so you can read and see what's going on. Friction on your bicycle wheel is good because the brake right there squeezes and pinches and rubs against the inside of the wheel, and that slows you down too. So good friction, these are good things. Now, too much friction can be bad. For example, that's why we put motor oil in our car engine, because we want to make sure that our car engine does not have any bad friction. We want things moving and gliding well against the parts of your engine of your car. So friction is a force, things that are touching, and good most of the time it seems like, and bad sometimes. Why friction occurs? Well, no surface is perfectly smooth. Even surfaces that look perfectly smooth, like this shiny aluminum foil, even though it looks perfectly smooth, if you look at the microscopic level, it is not perfectly smooth. So that's to know. Factors that affect friction. Well, there are two factors that affect friction. The roughness, we talked about that just a little bit. The roughness, the more friction, the more the roughness, the more the friction would occur. So that's why we put sand on icy sidewalks and roads. And we put salt, but sometimes we put sand too, and that grittiness that makes the surface very rough, which means that we have a little more friction, which means it's easier to walk. If you're on, if you go on an ice rink and you don't have skates on, then you'll have shoes on, and shoes are a little rougher. The bottom of your shoes are rougher than the bottom of the skate. So that's why it's a lot, not a lot easier, but it's easier to walk on an ice rink with shoes on because there's a little bit of roughness. The other factor that affects friction would be the force pushing the objects together. So heavy objects have a lot more friction than light objects, which is why if you were going to push a couch across the carpet, it would be difficult to do because that force of the weight of the furniture makes it difficult. Whereas, say, something light, something not as heavy would be easier. Friction does produce heat, that is true. The rubbing of surfaces on each other causes molecules to move faster. They're going to gain energy, which is good in some cases, and it gives them a higher temperature. Now, it does say when is friction bad. Of course, we talked about that before. In an engine, we don't want too much friction, and that can cause heat. Now, of course, if we're lighting a match, that's a good thing. We want to try to get something useful there. There are 4 types of friction. So let's go through these 4 individually. First one is static, and static acts on objects when they are resting on a surface. Now, even though you're thinking, well, when somebody's walking, they're moving. Well, just for a second, as you put your foot down on the ground, your foot is not moving. It's in contact with the floor. And static friction acts in the opposite direction of the force applied. So as my foot is pushing backwards, because that's how I walk, the floor would actually be using static friction to push me forward. So when you walk, there's static friction between your foot and the floor. When you walk on ice, you have less static friction. And that's why she's fallen. Hopefully she doesn't fall. Looks like she's going to recover. So it's all about static friction. Two things that are motionless, they're resting. The opposite forces on the applied force. And sliding friction. Well, sliding friction implies that there are things sliding, and that's right, so that's pretty easy to remember. Acts on objects when they are sliding over a surface. It is weaker than static. That's why once you get the furniture moving as you're pushing it, it's not too hard to keep it going. It's the beginning that's tough. Sometimes you might need a helper to get that furniture moving, and after that it's pretty easy. And again, we talked about pencil riding and brakes on your bike. We used both of those already, but that's sliding friction. Two objects that are in motion, so that's different. Static was not in motion. Rolling friction. Well, rolling friction is the friction force that acts on rolling objects. So you might think of something like a ball. The force of rolling friction is 100 to 1,000 times less than the force of static friction. So rolling friction is very weak. That's why if you were going to go get groceries, you would put them in a cart. That's why we put them in a cart. The grocery store doesn't give you boxes and say, hey, put your groceries in a box and now push that around the floor, because that would be tough. First of all, it would take a lot of force to break the static friction. There would be static friction between the box and the ground, not to mention it'd be pretty dirty. Static friction between the box and the ground. And then also you would have to keep the sliding friction. Sliding friction is, while it's less than static friction, it's a lot more than rolling friction. So putting these groceries in a cart, that's the way to do it right there. It's going to be a lot easier. Same thing. Somebody says, let's go exercising, and you're maybe a little tired, and you only have one bike, and your partner might be like, hey, how about I ride the bike? Like, I don't know, maybe I'll ride the bike, because that's easier, and it is easier. You don't have to apply as much force, and that's why rolling friction is so great, is because it requires a lot less force. The last friction is fluid friction. Fluid friction opposes the motion of an object through a fluid. Now, something to remember, this is called specifically air resistance, and a lot of people get confused, but fluids are not only liquids, but gases too. So fluid friction increases as the speed of the object moving through the fluid increases, which you think of swimming. Fluid friction pushes against you as you swim, and then because air is a fluid, even though it doesn't seem like a fluid, that pushes up on the parachute as the parachuter's going down. So those are your four types of frictions. Now you're going to do some assignments and some different things to look at these. This was just the basics. Give you some more examples and help you out. Try to figure out what's going on with this. All right. So check those out. Check the play posits out, and the CK12s do a nice job on that.